Hey guys, we're looking at exceptions in the straight line. Number 3, which of the following graphs correctly represent the line defined by the equation y is equal to negative x plus 2? So we call this one an exception because a lot of people say, well, hey sir, I don't see the a here. There's no number in front of my x. The y is isolated, which it needs to be, but I don't see a number there. Well, you'll remember from the video you just watched that there is a number there. We just don't write it. We don't bother writing the number 1 when it's in front of a variable. So we can rewrite this as y is equal to negative 1x plus 2. So there is a rate of change. The rate of change is negative 1. The question then is, well, which of these 4 graphs represents this situation? So we're going to do a little trial and error, or a little process of elimination, I guess is a better way of putting it. And we're going to look at this equation. We're going to start off by looking at the b. The y is isolated. We have an initial value of 2. We know that that means that that line has to cross on a Cartesian plane somewhere where the y is equal to 2. So if you look at the 4 lines that we've been given, you'll see that this one passes through 0, 2, as does this one right over here. And letter D down here similarly passes through 0, 2. So these guys are all in the running as far as the initial value goes. But if you come down here, one of these guys is not like the other, as the song goes, and you can see that that does not have an initial value of 2. It has an initial value of 0. It's passing through the origin, like the example that we just looked at in the last video. So it would have to be up here somewhere if it was going to match this equation. And so C is gonzo. There's another interesting feature on the A over here before we get too detailed, and that has to do with this negative. We know that negative slopes go down, and so whether it comes like this or like this or like this, whether it's super steep ski hill or a flatter ski hill, it's still going to be going down the Cartesian plane as opposed to one that's going to be going up the Cartesian plane. So, these are positive slopes over here, and these are negative slopes over here. And if you look at the 3 that we have remaining, this is a negative slope, and this one here is a negative slope, but this guy over here is a positive slope. This one's going up. And so we can eliminate B. And that leaves us with these 2. And this is where it gets a little bit tricky, because we need to know, well, which one of these slopes is going to give us a slope of negative 1. And the only way to really determine a slope is to plug in some points to the formula that we know. And so it doesn't really matter which of the 2 we test. I can test this guy right over here and see what happens. So I need a second point, and I can pick any point I want on this graph as long as it's nice and neat. I'll pick this point right there. I know that that's 0, 2, and right over here, that's the point 1, 0. And so when I plug these numbers into the A equation, if I get negative 1 for my slope, I'll know that's my answer, and then that one must be wrong. But if I don't get the right answer here, then that means this guy must be the right answer. Let's see. A is equal to y2, so I'll call this one x1 and y1, and I'll call this one x2 and y2. So y2 is 0 minus 2. 0 minus 2 over 1 minus 0. I think you can see pretty quickly that the A for that one is negative 2. So we know he's wrong because we need a negative 1, which means this guy is right. But I'll show you how we can prove he's right. And we can do that the same way by using that A formula and picking 2 points. We know that this is 0, 2, and we know that this is 2, 0, and we can call this x1, y1, x2, y2. So again, I'm going to use that A formula. For this one was for D, but this one is for A. So 0 minus 2 over 2 minus 0. And that's negative 2 over 2, which we know is negative 1. And negative 1 is the number we know that's in front there. So A is our answer.